everybody!
Hi, Dr. Nick.
Yeah, I got a few people who got the reference. Anyway, so I am here to talk to you tonight about smartphone features. This might be interesting because that's kind of what we're supposed to be going for, isn't it? Yes, that's kind of an omen. Yes. Yeah. So let's start out talking about the display. That's one of the more visual things most people notice about it. It's the shiny part in the front of the phone that you see things on, you touch. There are two major technologies that displays utilize. You have the LCD and you have the OLED. There's a few variations on this. LCD technology also has the LED, but that's really nothing but a different backlight display technology, and it's not really hyped up as much in phones as it is in TVs and stuff. You also have the OLED, which is organic light-emitting diode. Its main major alternative version is the active matrix OLED. The main advantages of LCD are it's an older, or as you might want to also say, more mature technology. Yes, it's an advantage. It's a cheaper technology as a result of being more mature. And it's a much more durable technology than OLED. The main problem that OLED has is, in fact, it'll burn out much more quickly than LCD will. However, OLED has much better contrast, color, viewing angle, responsiveness. Pretty much everything about it is better, except it'll die within a year or two. But most people replace their cell phones every 2 years anyway, so not that big of a deal. The main difference between OLED and AM OLED is that the active matrix OLED will last longer. That's pretty much its only major advantage. So, physical size. This is exactly what it sounds like. Most phones are in the range of 6-ish inches by 2 to 4-ish inches. The Galaxy Note kind of pushes that boundary up a little bit bigger than it otherwise would be, but that's the range you're generally going to have to work with if you're making apps for phones. Tablets are obviously bigger than that. They go for about the 7 to 10 inch models. Oftentimes you'll get a diagonal measurement. Instead of having height times width, you'll just get a diagonal measurement, and it's usually approximate. So 7-inch tablets aren't necessarily 7 inches on either side. They're usually about 6 by 4-ish or something like that. Resolution. This is probably something you'll be a little bit more interested in as a programmer. Resolution is the number of pixels that you have on the screen. It's you can either get it measured in dots per inch or in terms of actual resolution, where they give you the height as measured in pixels and the width as measured in pixels. A picture, for those of you, or a pixel, for those of you who have absolutely no graphic experience at all, is short for picture element. Too many things that start with pic in this. It's basically a single point of color. So each one of these little squares kind of represents what you would have on the screen. That would be green, that would be yellow, that would be blue, etc. Now that I think about it, if you don't have any graphics experience at all, you might also be interested in knowing the fact that there are actually 3 colors that you have control over: red, green, and blue. There is no yellow. That's subtractive color spaces. I probably should have put a little bit more about that in here, but I didn't think about it until just now. Aspect ratio. This is probably a more important thing to be aware of than the actual resolution. There's tons and tons and tons of resolutions, but they all tend to fall into similar width to height ratios, and that's actually a thing that'll throw you a lot more when you're designing user interfaces, because it's a lot easier to make a user interface that fits on. Whoop. It makes it a lot easier to hold on to your pen when you're going to draw on a whiteboard. It's a lot easier to draw an interface that works both on this screen right here and this screen right here if they happen to be scalar multiples of each other. It's much more difficult to make an interface that'll work on this and on this. Generally speaking, when you have large changes in aspect ratios, when you're going to have to make the biggest differences between your user interfaces, you probably for a difference like this, you'd probably want to have a completely separate user interface for those two different aspect ratios. But as long as you have the same ratio, the resolution isn't as important, although, well, actually the resolution isn't important. It's the physical size that will actually make it change. If you have a device that's this big versus a device that's this big, you're probably going to have a lot more detail on this one than you would on this one, even if they were the same aspect ratios. But you can just simply scale up a small user interface to a larger one. That works reasonably well, although it's not optimal. As you can see here, you have the most common aspect ratios are 3:2. That's most of your iPhone type products. You have 4:3. That's your iPad and all of its iterations. And you also have 16:9. That's much more common in the Android space, and that's probably the most common resolution outside of the tablet market space as well. So if you're trying to make some sort of interface that would also work well on like a computer screen, 16:9 is very, very common there. It's also very, very common on TVs, which are probably going to be becoming app aware in the not too distant future. Yeah, as I said, these are some of the more common ones here. I just sort of put them all on here. This is your 4:3. This yellow one here is your 16:9. You have much wider ones available. Although, like I said, the 3:2, 4:3, and 16:9 are the most common. Density. As I mentioned, this is another way you can measure the resolution. This is a less precise measurement. This is something that's generally used more by consumers than by programmers, but it's still an important thing for you to keep in mind. It's usually when you're measuring areas like the entire screen, and pixel density will affect you less if you use reactive designs. So if you write your user interface such that you say it takes up 50% of the screen versus 4 pixels, well, that'll look the same on this one and this one more or less. Whereas if you said 4 pixels wide, it would be this wide on this one and this wide on the other one. You all see how that would be. It's easier to work with percentages of a display sometimes in most circumstances than it is to work with actual pixels in terms of fitting across multiple devices, right? That makes sense? Does anyone not get that? Okay, good. You also have other measurement that you can use, like EMs. That's common in web development, and there's density-independent pixels, which is at least used on the Android environment. Oh, almost dropped my laptop. Anyway, so display standards. Here's this is a common listing of display sizes. A lot of these come from the television and the desktop computer world. Most of you probably recognize VGA. That's an ancient standard, but it's largely the basis of what a lot of the other standards have been since then. You have HVGA, which stands for half VGA. It's got half the width. This is what the iPhone is. You have wide VGA, which is wider. This is what Android standard is built on, although it's actually not the most common. It's just what Google pushed out originally. I forget what this one stands for. I think it's full width VGA. Yeah. This one, it has an actual 16:9 aspect ratio. That's its big distinction from this one. These are actually two of the most common Android resolutions. You'll notice there's only a 54 pixel difference between them in one dimension. And a lot of times that 54 inches is actually taken up by the Android's own UI elements. So the fact that these take up a large majority of the Android marketplace, actually, or market space, is actually kind of interesting, because it means if you target this, you'll cover a large majority of your market space. But anyway, DVGA. This is what the iPhone has. It's another. You'll notice it's another 3:2, just like the original iPhone. You'll notice the iPads, the original iPad, the iPad 3 or the third generation, whatever you want to call it now. They both have the exact same aspect ratio, even though the iPad 3 has its magical Retina display that's supposedly got such density you can't see it if you look at it really close. 16 by 9 is very common in HD TVs. We have the old 720p, that's 1280 by 720, 1080p, which is 1920 by 1080. We have a upcoming standard, which is just starting to get used by televisions, ultra high definition, where you have the 4K and the 8K. Those are new standards. You'll notice they're all 16 by 9, 16 by 9, 16 by 9, 4 by 3, and we also have 3 by 2. So if you basically just cover those three aspect ratios, you'll probably have something that'll work on almost any device. It's one thing that's important to keep in mind while you're trying to deal with display fragmentation. Now this right here is a fairly well distributed picture from online. This shows all of the different Android devices with their display sizes overlapping upon each other. Now one thing that is kind of interesting you'll notice is that the upper corner of almost all of them tends to fit right within this little band right here. That's because most of them are one of two different aspect ratio types. You have the 4 by 3s and you have the 16 by 9s. So once again, as long as you cater to one of those two resolutions, both of them, you should be able to cover all possible resolutions as long as your layout is dynamic enough. Has anyone got any questions or comments about that?
You have the iPhone 5 resolution off. That was for 4S.
Was it the 4S? I'm sorry.
The iPhone 5 was bigger.
Okay. Is it the different aspect rate?
Yeah.
It is?
Longer.
Oh, it's longer? Okay. My mistake. 4S, not 5. Anyway. So, that's pretty much all I have to say about the display, the actual presentation layer of your phones. Touchscreens. I'm sure you all are well aware of touchscreens. They're the main interface that you have with your smartphone devices. They have a transparent touch sensor that goes over the front of the display. And there's two main technologies. You have the old resistive technology. This is what touchscreen used to mean for years and years and years. And you have the capacitive touchscreen technology. The main advantage of capacitive is that you can have multiple touch points measured at the same time. I've debated whether or not to even talk about resistive touch because it's uncommon, but it's important that you know the history of it. And if you're going to be a mobile developer, there is possibility that you might end up in a niche market where this is actually important. Resistive, basically what you do is you have two layers of some sort of a transparent material that's conductive, and whenever you touch it, you push the top layer into the bottom layer, and that's how it figures out where the touch is. It sees where that contact happens, and it's able to measure that. Yeah, contact allows the key.
How big is that gap between?
Very, very small.
Like microns?
Yeah. Yeah, like
Millimeters?
whoa, much less than millimeters. It might. I would say that the biggest gap it could possibly be is like 1/10 of a millimeter. That would be a huge gap. Now, the big advantage with resistive technology is it allows you to use anything to touch it. A lot of times, this is what you'll remember if you ever used any sort of touch screen technology back in the 90s. You'd have a stylus for doing stuff. But you could use your finger and it would still work. And that's the resistive technology's big advantage, and that's why you might actually encounter it at some point. If you end up working for some company that makes mobile apps for warehouse distribution, there are Android-powered little scanner thingies, and you can write apps for those. Resistive touchscreen is king in the industrial market because you can use gloves you can wear gloves while you're using it. So people who are sloshing about in meatpacking plants and then they have gloves on because it's a FDA regulation. You can't use capacitive touchscreen technology while you have gloves on. It just doesn't work. Resistive you can because you can use anything to touch it. That's all I'm going to really say about resistive. Capacitive, that's the way of the future, and that's what most of you are going to end up using. Basically what you have is you have a single conductive sheet and it's given a charge. If you ever place a conductive material, like a finger, in contact with this sheet, the charge will discharge into that conductive material, and the drop in charge it'll be able to figure out where exactly that is. You look like you have a question. No? Okay. Yeah, basically what happens is you'll have 4 points. And there's a charge within this little square right here, and you touch it, and this point right here will lose its charge faster than these ones will. And so it'll be able to figure out, oh, you got your finger down here. And then it'll have an array of these all over the screen. If you ever look at your smartphone and you hold it up at the light at the right angle, you'll see a little grid of dots. That's what this is. Each one of those dots is a different place where you can have a separate touch point. And that's basically how it works in a nutshell. It allows for multiple touch, and it's almost universal. I have seen a handful of resistive touch Android devices. They're always the low-end models, and except for, obviously, the ones that are purpose-built for industrial purposes. It's almost ubiquitous. 3D graphics. This is something I personally have a lot of experience but I doubt most of you guys are going to actually be that interested in it. 3D graphics is typically done through the OpenGL ES2, usually, specification. The basic gist of how 3D works is you define an object by a bunch of points, and then you connect those points together to make triangles. You project those points onto the screen, the triangles retain the relationship, and you use linear algebra magic in order to do all of this. Matrices are involved. Points are then rasterized after they are put into screen space, and each pixel is given values which are based off of interpolated values that exist at each of the 3 points of the triangle. If you are using the ES2 standard of OpenGL, which is the one that all the modern hardware uses, you're able to write shaders, which actually allow you to basically write a teensy little program that runs for each and every individual pixel. Also every individual vertex, which is the point on the triangle. Does anyone want me to elaborate on any of this, or? Yeah, I didn't think so.
That goes a little bit with the pointers.
Oh, okay. Well, I didn't actually think anyone would be interested in this, so I didn't put that too much into it. Basically, what you do is you have an object, and well, you have a bunch of points. You know, point, 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 and you have a bunch of lines that connect them. So you have points, and you say that is a triangle. You have a list of basically indexes to all these things. So you basically have a list of the points, point 1, point 2, point 3. And as you heard in the previous class, it's all in an array, so you'll have a buffer that's full of memory locations. So you'll have 1, 2, 3. And that's the list of points. And of course your points are listed in a separate buffer over here, which each have three positions. Technically you can have 4, but usually it's only 3. That's the positions of the point in the X, the Y, and the Z position. Does that make sense to everybody? Am I going way too fast?
What's the fourth?
W, but it's sort of not really ever used. 4-dimensional vertexes. You can push off 4-dimensional data into a vertex buffer, and that can be useful for other things, but usually you don't.
Okay.
There's edge cases where it's useful, but most of the time you just need your X position, your Y position, and your Z position. Did I do that backwards?
Yes.
I have dyslexia, I'm sorry. Yeah. So for each vertex you'll have a point, and you can have other data associated with this. Perhaps you'll have another X, Y, and Z coordinate which say which direction that surface points at that location. Does that make sense? Mm-hmm. So for example, right here it's pointing up, right here it's pointing over. You'd have one point which says the location of this point, and you have another point that says the direction it's pointing. Mm-hmm. So you can have all sorts of data associated with each vertex. You can have a color. This is brown right here. This is also brown, but it's a slightly different shade of brown. That's red. You can have that sort of data pushed along with it. Usually what you'll have is a positional coordinate, which is 3 floating point numbers, a normal component, which is 3 floating point numbers, and you'll have 2 floating point numbers which reference a position on a texture map. That's the typical usage. You can have additional texture coordinates too, though.
3 floating point numbers for texture map?
No, 2 for a texture map. Although technically you can have 3. There are three-dimensional textures, although I'm not sure if ES2 supports that or not. Question?
Yeah, this isn't really relevant to anything, but you said that shaders are a small program. I've never thought of it that way.
Yeah, it's basically it's a function that gets called, but I mean it's independent of the rest of your program.
And they just all happen in like a random order. It doesn't really make a difference.
Yeah, they're fed. Basically, what happens is this stuff gets translated into screen space, and it's impossible for me to really draw that. You have this amalgam of stuff here, and you run it through a matrix, and it ends up getting put on a two-dimensional board like I have right here. And then all the values that you have for each vertex, they get interpolated between these points. So it'll figure out what the value is right here and right here based off of what you have in vertex number 1 and vertex number 2. And so it's closer to 2, so it's more like 2, but it's still got a little bit of 1 in it, so it's somewhere between there. It uses a linear interpolation algorithm. And then once you get that for both of these 2 points, you do that for all the points between here for each pixel. And that's, in a nutshell, how 3D graphics works.
On the iPad, I use to learn how to play the piano.
Mm-hmm.
And when you strike it, it does a shadow. That is something like that?
I'm not sure. I'd have to look at the actual graphics. But if it's 3D,
Yeah,
if it is actually 3D, not just simply pre-rendered
it's got a
3D,
vertex.
then it's quite possibly done with 3D graphics. Shadowing is an interesting topic that I could spend hours talking about in and of itself, but then we'd never get to the rest of the smartphone features. Is everyone satisfied with my talk on 3D graphics? That was kind of a tangent. Or does anyone want... Yeah, for games is the most obvious usage of 3D graphics. But you could also use it for things like navigational software. You can use it as a file menu representation. You can use 3D graphics for anything, really. But the main usage is for games, yes. Any other questions? Did anyone absorb any of that? Because that was completely impromptu.
Yeah, it sure makes sense.
All right, cool.
That's actually kind of the
Maybe I should have an entire class on 3D graphics.
That is very interesting.
simplest explanation I've heard for how 3D graphics work. So, bravo.
All right. Yeah, and there's caveats to that. You can like just send it lists of points without having the indexes, but anyway, internet. All smartphones have internet. All tablets have internet of some sort. The most common connectivity technology for getting the internet or any other sort of network connectivity is Wi-Fi. You've all probably heard the name Wi-Fi before. Wi-Fi was introduced a few years ago in the late 2000s by the IEEE, the standards body. It's slightly catchier than IEEE 802.11 standard B direct sequence. It's slightly more consumer friendly. Basically Wi-Fi covers the entire 802.11 standard body, even though it was originally intended just for B. You have 3 main versions that are typically supported by devices. You have the B standard, which is the oldest. You have 11 megabits a second, not megabytes. Interesting thing about B is it had some security, but it was really, really crappy. That's one of the main advantages that you got with G. It had much, much more secure security than B did, although it has since been cracked. You have considerably faster data rate speeds, although the increase that we got with N was a bit more substantial. Of course, the caveat with the N standard is it doesn't require that a device supports that level of speed, and it depends a lot on the number of antennas that it has and a whole bunch of other stuff. But anyway, you have the 3 main standards that are available with Wi-Fi, B, G, and N, and yeah, that's Wi-Fi. You also have the G standards. This is sort of an informal classification of a whole bunch of different standards. You have the original 1G. This was analog signals. It was capable of transmitting data rates of about 3 to 6 kilobits a second. If you ever see on your phone it says 1G, that basically means you have no internet, but it can still hear the tower off in the distance. 2G. This is when they actually, huh?
You can still use the meter.
Yeah, it can still. There's a signal somewhere. It just can't actually make anything out. 2G. This is when they actually started using the G postfix for stuff. 1G was applied retroactively. 2G is what was developed in the 1990s. It's an actual digital signal. Some of you might remember there being commercials about cell phones. PCS, it's amazing, it's so clear. Yeah, this is when that was 2G. The digital signal. This is when you started getting 56 kilobits per second, 115 kilobits per second data rates, mid-90s internet speeds by the end of the 90s. In the 2000s, they started rolling out with what was called 3G. I'm sure you all remember 3G because that's when they started actually putting it into commercials. I remember T-Mobile was the one that was really big about advertising them having 3G. That's when you started having actually usable data rates, where you started having 380 kilobits a second up into the megabits range. And then we get into 4G, which is just now rolling out, LTE. Yeah, we're all aware of that. We got even Sprint has LTE now, in a few places. It's kind of shouty. 4G technologies are expected to have 10 megabits a second to gigabit speeds, although I haven't actually noticed that. That's the future, and data rates have been growing exponentially. Yes?
So, in this past week, some people criticized the LIPA workers for standing there and having maps on paper. So, there are areas of South Shore that have no cell towers.
Yep.
There were absolutely no cell phones whatsoever. So, what technology could they have used to transfer this information had there been no, except for satellite?
Hypothetically, they could use a satellite. They could have downloaded it before they went out there.
What do you mean?
They could have used Wi-Fi if there's internet at all available in the area. What do you mean? What do I mean?
I have Verizon, I have Clear, I have every hotspot imaginable. The only one that worked was Verizon.
Mm-hmm.
Clear didn't work, and I had to let my Verizon to my sister, so I had no internet. What should I have been doing? Get a bigger antenna, you know? Wi-Fi.
It's not something that you as a consumer really have a lot of control over, huh?
No, Wi-Fi I can go like
The
2
ham
miles.
radio,
I gotta
that's the only
repeat
thing
it.
that'll work.
Yeah, you can always hook your phone up to a ham radio. Yeah, but yeah, you can get like satellite receivers. You can get internet that way, hypothetically speaking. Those aren't actually part of your
It would work.
phone,
The
though.
cell phone would work if it.
You would be able to get data by hooking up a satellite receiver to a Wi-Fi hotspot. You would not be able to get voice.
The latency is too much.
You won't get voice, but you would get eyes.
You'd be able to get internet. You'd be able to download map data, for example.
And I can send messages and so on.
Yeah, yeah.
Well, and in theory, you could get on Skype or something.
Yeah, hypothetically, you could do something like FaceTime.
But the
Apple.
latency would be way too much. So
Yeah.
It would probably be irritating, yes.
They're pretty crappy, but better than nothing.
It's coming with us. All right. So yeah. So basically, in a nutshell, wireless connectivity technologies, wide area wireless connectivity technologies, have been getting better at an exponential rate, and they've been getting better. Unfortunately, this doesn't take into consideration the bandwidth crush. That's actually becoming a major issue. We're running out of actual bandwidth.
3G was working though.
Well, right, but 4G uses up a lot more bandwidth than 3G does, because the way 4G works is a lot of the 4G, I shouldn't say 4G like it's a monolithic thing, but a lot of the current technologies, 3G, what you'd have is you'd have a tower, and it'd have its little thingies on top, and it'd send out an EM wave, and that would connect to a phone, and that was pretty much it. 4G, you have a whole bunch of different waves at a whole bunch of different frequencies, and each phone has to take up multiple bands, and
Packet.
the thing is, you can't send two signals to two different phones on the same channel at the same frequency at the same time. So you only have so many frequencies you can transmit on. There are discrete intervals upon these different bandwidths. Understand? So that's where the whole bandwidth crush comes in from. But that is a slight sidetrack. I've heard a lot of promising news about new technologies that may address this, but as of right now, it's a major problem in the telecom industry. You had a question?
Why is it like like when you go to certain places, they tell you can't use your cell phone. They imply that your cell phone's going to interfere with their.
You mean like in airplanes?
Sometimes it's doctor's offices, like the
Um,
employment office.
Cell phone also translates.
Well, the way that this kind of goes into the low-level engineering of how wireless stuff works and all. Basically, you all know how an electromagnet works, right? You run a coil around a piece of metal, you run current through it, it produces a magnetic field. You run around the other direction, it produces a magnetic field the opposite direction. When you transmit stuff, it basically flips that back and forth a billion times a second. And interesting thing about moving electromagnetic waves, if you were to put another electromagnet on the end of the one that you're fooling around with, every single time you plugged it in one way or the other, the one that you didn't have plugged into anything, it would develop a charge. And that's even if they were separated by a distance. And that, in a nutshell, is how wireless technologies work. That's how radios work. So, certain frequencies interact with certain electronics in a certain way. And you can end up picking up an electromagnetic signal that you're transmitting in devices, in parts of devices that you really don't want them to detect that. It'll end up causing it to behave erratically. So, hypothetically speaking, a cell phone could cause a certain piece of sensitive equipment to fail. It'll be picking up the signal that your cell phone's trying to connect to a tower with, rather than picking up the like an MRI, for example, picking up the radio waves that are coming out of your body when the magnetic field collapses in that thing. A lot of those sensor type equipment that medical environments use, they're very sensitive, and cell phones are very loud.
But in a non-medical environment, like like say the unemployment office or another office, where they're not like getting out the paddles and trying to bring someone to life.
Honestly,
Is
they
that
just
just-
don't want you to.
Yeah, they probably just don't want you. I'm guessing in the majority, even with the really sensitive electronics, where it's hypothetically possible that it'll interfere, it's not realistically that likely that it's going to happen.
I just, was wondering whether I should offer them a foil hat or
Yeah.
something,
They really just don't want you tweeting.
Well,
A lot of the times, I think a lot of times those regulations are mostly there either out of,
Extreme paranoia,
what's the word, liability reasons.
Flaming ignorance.
flaming ignorance.
I think they're mostly doing it because their insurance companies say, hey, there's a hypothetical possibility that this might interfere with stuff. And so they make a regulation saying that you can't operate a cell phone around there. Or they just don't want you to talk on your cell phone.
It's mostly the latter.
I'm going to guess it's mostly the latter, but that's politics. And I don't like to make political statements. Anyway, all right, so that's wireless connectivity technologies. Everyone clear on the whole Wi-Fi thing? Okay. All right, so keyboard. Apple has been leading the crusade on the annihilation of the physical keyboard. One of the reasons why I hate Apple, I got myself a nice new phone. It's got a nice new physical keyboard. I love physical keyboards. I can actually type on them.
You, sir, are a Luddite.
Why are you so opposed to the advancement of physical keyboard technology? You, sir, are a Luddite.
Wait, what?
Anyway, hardware keyboards. Their advantages are they allow for faster input and they are less error-prone typically. Soft keyboards are cheaper to manufacture because you don't manufacture anything. It's entirely software. They're more flexible. That is, you can hit a button and all the keys will change. And they're more robust than physical keyboards because physical keyboards, if I drop this phone at the wrong angle, the keyboard's going to break. Also, a disadvantage of software keyboards that hardware keyboards don't have is software keyboards use up screen real estate. So there's pros and cons to both approaches. I personally love the hardware keyboard because I like typing really fast and not having to hit the backspace button, and then when I hit the backspace button, it hits P. And then enter.
You're using your software keyboard wrong.
My software keyboard just hates me. Anyway, so that's the main distinction there. There are, if you're targeting entirely iOS devices, you don't have to worry about hardware keyboards, but you do have to worry about your screen getting covered up by the keyboard while the user's typing. If you're developing under Android, it's a massive world of chaos, and you can have anything in the world. You can have different keyboards installed. It's wonderful for the end user because they have all sorts of choices, but you might have to take into consideration the fact that when they hit that button, it's not going to take up the screen, or it might.
I was going to say, I've seen ads for for keyboards for iPhones, would the keyboard interface then be emulated? Like you wouldn't
Ah, yeah, that's a good example. There are like Bluetooth keyboards you can get that'll work with iDevices, in which case you do have to worry about it. I've honestly never actually used one, so I'm not entirely sure the details on how that actually works as far
I'm
as...
just curious from a coding perspective, would you be
Oh, you don't have
able
to.
tell from the
You don't
software
actually have to.
which-
You don't have to. You don't actually deal with.
okay.
Yeah. You don't have to like look. Is it a physical one? Is it a?
Okay,
so-
you don't need to
yeah.
know that. You don't have to
The main issue that you have to worry about is it going to is the keyboard going to be covering the user interface while they're typing? Because if you're writing up some sort of software that has, for example, a WYSIWYG interface, what you see is what you get. They're not going to see the update live as you type stuff in. Under most for most models, only people who have physical keyboards would be able to see that sort of stuff. Or if they're holding it in portrait mode, they might see it at the very top. But that's the sort of thing you have to concern yourself as a developer with the different keyboard styles. But you have a question?
Well, there's one other thing. If they're using a Bluetooth keyboard and you brought up a keyboard that would normally only be a number pad, and don't expect them to put in characters, now that they have the different type of keyboard.
Yeah,
you
sort of,
can get
kind of.
new input that you didn't expect.
That I don't think that would really be that big of an issue in most of the software you'd have to design. I mean,
You might have to do some
They would-
checking you didn't think you had to.
well,
I think that's handled by the OS. Like,
Yeah.
if you say that you want a number pad for your keyboard,
But what if
and then you
using
have a Bluetooth keyboard,
that has
I think
AV?
the OS will reject everything
Yeah, it's-
that
it's-
wasn't
Okay,
it's all standardized. All you get is a stream of strings. You don't have to worry about actually like pulling a device or anything. What you'll get is there's interfaces in the software that you'll get a string out of basically.
Okay.
You'll write a function that accepts a string as a parameter, for instance, and that'll be something that came from a text box. You'll be coding like on change handlers. So whenever somebody changes the value in a text box, that function that you write will get fired, and it'll get past a string, and that's how that sort of stuff works. So you really don't have to worry about this as far as detailed, technical, low-level stuff. It's mostly high-level user interface design type stuff that it affects.
Like shortcut tabs and stuff like that, right?
To an extent, yeah. Yeah, if they don't have a shift control key, you can't make shift control X do something, you know. Although I'm not sure you can really do that too much in mobile devices. But anyway, that's keyboards. That's one slide. Wow, we spent a long time on that. Trackball. This is a feature that's occasionally seen in Android devices. It's very common in BlackBerry. Apple does not use them at all. So if you're planning on targeting iOS, you don't have to worry about trackballs. But it shows up enough in Android that you can write apps that can take advantage of it. It allows you to have much more precise control over the position of stuff, but it should never really be considered necessary. If you're writing an app that requires fine-grained positional control, you're doing it wrong. So trackball, it's a nice thing to keep in mind. If you happen to be writing apps for BlackBerry, which we don't really go into, it's something you can count on. If you're writing for Android, it might be there. Camera. So almost every single smartphone, in fact, I'm not aware of a single one that doesn't have a camera of some sort. A lot of times you'll actually have more than one. You'll have one that's pointing front and one that's pointing back. The image resolution is typically described in megapixels. They don't usually tell you what the actual resolution is when you buy a device, but oftentimes the aspect ratio of the cameras is about 4:3. But that's just sort of common standard. It's not guaranteed by any stretch of the imagination. There's basically two major technologies that you have with digital cameras. You have the CCD, which is charged coupled device, and you have the CMOS, which is complementary metal oxide semiconductor. The basic gist of it is CCD has better quality and CMOS uses less power. That's pretty much the pros and cons of the two. Sensor size is always a better determinant of image quality, but you're not actually buying high-quality cameras, you're buying smartphones, so that's not really that important. Speakers. A lot of smartphones have speakers built into them. They're available in a high variety of quality and power supplies. I've actually seen an Android device that had flip-out speakers. It's kind of crazy. I was trying to find a picture of it because I'd seen it. I just couldn't find it. Available in some devices with not just one speaker, not just two speakers, but even 4 speakers. I've actually seen some quadraphonic sound systems on some Android devices. It's crazy. I don't know what the hell they're thinking. I don't remember. I just remember seeing surround sound available.
What do you do? Put it inside your hat and walk
I'm
around?
guessing the idea is you plug it into a real stereo that already has the speakers set up. But the fact that it's just available at all is just kind of ridiculous in my opinion. But yeah, there's a large variety of qualities. So if you're designing apps, you need to keep in mind that not everyone's going to have the best speaker. Some people are going to have really loud speakers. You need to take that into consideration when you're designing stuff that requires sound. Microphone. Every single smartphone has a microphone, because if it didn't, you wouldn't be able to make calls. Some of them can have several. This is used for noise cancellation and stuff like that. There's a very wide variety of quality for microphones. Keep that in mind when you're designing your apps that require voice input. Sensors. There is a very wide variety of sensors that's available in the mobile environment. Generally speaking, what sensors do is they monitor certain variables about your environment, and they can allow for all sorts of useful, interesting usability features. A lot of the sensors are included in a phone for a very, very specific purpose, but then you can sort of use them for other stuff. That's kind of neat. I've seen, for example, I'm not sure if it's the most popular app in the App Store for Apple devices, but it's definitely in the top 10. The Flashlight app. Y'all know that? That's not exactly usage of a sensor, but it's using the flash for the camera. It's a clever usage of something, a piece of hardware that was built into the phone for something that was not intended for. It was not intended to be used as a flashlight, but someone used it and it's now.
Burn out.
Well, yeah, if you leave it running. Oh. But only an idiot would leave it running. Yeah, but that's an example of using a piece of hardware that was intended for one thing, but being able to leverage it for something else and it becoming incredibly popular.
Well, it only gives you 3.5 hours.
3.5 hours, really?
Well, I was doing electrical work and it was in the dark. That's why I got a new one this week.
Did you also get a flashlight?
No, actually, it burnt it. It burnt it.
$400 flashlight.
If you leave it on, it will burn it. It just burnt it. And I was like, oh.
A $400 flashlight made by Apple. That doesn't surprise me. Anyway, so probably one of the first sensors that you think about when you think about mobile devices and sensors is accelerometer. Accelerometer is really neat. It detects changes in motion, detects gravity. So if you throw your thing up in the air, it'll figure out, oh hey, I'm being accelerated as it goes up. And it'll be, oh hey, I'm free falling. And it'll be, oh hey, I just got broken. Most accelerometers operate on 3 axes. So just like in my graphics explanation, you have the x-coordinate, which goes like this. You have the y-coordinate, which goes like this. And you have the z-coordinate, it goes like this. It measures how much acceleration it's getting in all those relative to the device. Can be used for interaction with by just moving the phone. So you can have things where if you shake the camera going this way, you can do something. There's a really popular app I remember at one time where you could go like that and it'd be like a gun. I forget the name of it though. Another a fishing one? Yeah. See? These are all just sort of clever usage of accelerometer that it was never really intended for. Another neat thing that an accelerometer can be used for is detecting bumps. So you can actually have an app that would respond to strong, sudden G-forces. So you'll be able to just have something like where you tap it in the side and it'll move on to the next item. Stuff like that. Related to the accelerometer, you have the gyroscope. Whereas the accelerometer detects motion moving in these directions, the gyroscope detects rotation. So you can use the gyroscope to, for example, you're holding your phone like this, you go like that. It'll detect that it's been rotated 90 degrees, and you can do something with that. The gyroscope typically gives you some indication of how much rotation has happened along the 3 axes. So it'll, instead of being how much it's moved, it'll be number of degrees that it's rotated. I think it's usually in radians, but I'm not sure. Yeah, oftentimes it's used to control a camera in a 3D environment. So if you're having some sort of application, let's say you're writing an application that stitches together a whole bunch of photos to make a panorama. You can use this thing to figure out kind of roughly where the camera is situated in its little 3D bubble. Any other sort of environment like that. So I've seen it used in a lot of games for first-person shooters, where you use it to look around, in addition to being able to do it with on-screen controls. It can also be used for doing some sort of gestural stuff, which is basically what I just described. GPS. This is actually a wider area of discussion than I thought it would be. GPS is the Global Positioning System, and I'm sure most of you already know that. Basically what it does is it'll provide accurate longitude, latitude coordinates. Interestingly, it can also provide fairly accurate altitude, although not all devices actually supply you with altitude data. If you combine it with map data, you can actually get navigation, which is a fairly standard app that's already deployed on stuff. Recently, there's been devices come out with what's called AGPS. It means assisted GPS. It uses additional information to approximate your position before the GPS actually locks onto all the satellites. This helps actually lock on faster, and it gives you sort of a general ballpark location before that happens. Basically, a GPS works by looking at what cell phone towers it's connected to, and the carriers know where their cell phone towers are, so they say, well, you're between these 3, so you're probably kind of right in this sort of general area. What was that?
Yep, triangulation.
Yeah, it triangulates. But it's not very accurate, unfortunately. You can also use additional things, like it can look at, see what sort of Wi-Fi hotspots it's looking at, and there's data for figuring that stuff out. If you are connected to a hotspot, it will be able to tell
That's
the.
when it's more accurate.
It does get more accurate with that, because the ISPs actually have databases of the geographical locations where a particular IP address is likely to be stored.
5 meters.
It's bigger than 5 meters. It's like a neighborhood size, because IPs bounce around all the time. The best it could hypothetically be is the size of a building. But yeah, that's assisted GPS. I've also noticed that a lot of the recent smartphones have been supporting GLONASS, or GLONASS. I'm not sure how it's pronounced exactly. This is a Russian alternative GPS. It's actually been in development all this time, and nobody's been using it because it's been not...
That's the magnetic field one, right?
I'm not sure the details of its differences. I thought it just worked pretty much exactly the same as GPS, but they...
The Earth, I studied it for months.
Oh, you did?
The Earth, again, I went to see the guy. The Earth gives off a magnetic field.
Right.
And that impulse sphere field is measured, and then they put metrics involved into it, and what they do is they outline like with an AutoCAD software, let's say a building, and they can actually tell you from inches away where you are in a room.
I'm not sure if that's the same thing as this. This is actually using satellites.
Well, the satellites are the first point, and then the magnetic field, they put the two technologies together.
Right.
And I can bring you some information about that.
Might be interesting. I'm not. It's kind of technical for this though.
The most accurate GPS available right now, and it's the one that's least funded.
Yep. Yeah, I was actually going into that. Russia's been working on this for years. It just sort of sat in purgatory for like a decade, and then they got it refunded. It's like almost the entirety of their space program is dedicated to this now. It has advantages in high latitudes and in urban environments, and a lot of smartphone devices are actually supporting it recently because when you combine it with GPS data, you'll get a much more accurate GPS fix. Do you have something? Anyway, yeah, this is a new feature that I've noticed coming out in a lot of new smartphones. I'm not sure if the iDevices support it yet, but I wouldn't be surprised if the next generation did. Compass. This is exactly what it sounds like. This is a sensor that tells you what orientation you are in the world. Unlike the gyroscope, this gives you like a global orientation. So a gyroscope can suffer drift. It has a certain amount of error in it. So every single time it changes, it's slightly inaccurate.
If you go in the same direction for the same amount of time, then it's accurate. If you lose the direction in any shape,
Well, right.
up, down, or to left or right, you lose the frequency.
Right. But anyway, there's error associated with it because it's simply represented with floating point numbers, and floating point numbers are inherently lossy. You'll always lose some resolution with that. So, unlike a gyroscope, a compass will always tell you which direction it's pointed, although it might not be as accurate. It's oftentimes used with GPS to provide a better experience because you can figure out your orientation based off of GPS coordinates. So if I'm moving this direction, I know that I'm moving to the east, but if I point my camera, if I'm not moving, I can't make that sort of determination.
For depth finding, they use gyroscopes for depth finding peaks. And they use a sonar.
Right.
And then that's how they determine where the gyroscope is actually stopped working. And they reposition it. For one depth, in other words, it's going straight down.
What's this for?
For sonar, to see how deep the actual ocean is, or the cavern is.
I don't think many.
Yeah, really do that on your phone.
Yeah, I don't think many.
Sonar's for water.
There's a lot of new sensors coming out in the smartphone world, but I'm afraid sonar is not one of them yet.
Why?
I don't know why. I wish they would come out with it. I have so many things I could use sonar for.
Finding fish.
I mean, just imagine fishing. I mean, you could just throw away that fish finder. Just put the phone in the water.
There's other commercial, shockproof, waterproof, blah, 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 blah.
Sonar.
It has it in there.
Next
It's an Android
Hurricane
app.
Sandy, you need to get out of Brooklyn.
Yeah, well, just imagine you're trapped in a building and it's flooded, and now you need to find your way out before you drown. Sonar. Anyway, do not have sonar yet, but we do have proximity, which is kind of similar. The proximity sensor, which has been on some of the more recent ones, it's not that recent. Basically, it determines if there's something near, like something near the face of the phone, like maybe your ear. Its main usage is the touch interface whenever you're talking on the phone. A lot of times it's actually implemented as a light sensor or an infrared sensor. But that usually isn't that's a technical detail. It usually isn't that important. Generally speaking, the proximity sensor will tell you if something is close to it, but you usually cannot rely on it to be fine-grained more than close to it or far away. Although there are some devices that will report that sort of information. I don't know what sort of alternative stuff you could use it for, but you're all clever people. I'm sure you can come up with some amazing app that uses it. I don't know. Ambient light. This is an ambient light sensor. It detects ambient light. Basically, that's the light that's in the room. Its main usage, the reason why it's actually there, is for figuring out how bright the room you're in is, and therefore how bright the screen has to be. If you're in a bright room, the screen has to be brighter so you can see it. If you're in a dark room, it doesn't have to be that dark. It's also useful for figuring out roughly if they're in a daytime or nighttime environment. That might be something important that you might want to consider when you're designing your UI. Although, it probably isn't that important. I don't know. Barometer. Some phones actually have a barometer.
That's cool.
This is ridiculous. Why do you need a barometer in a phone? It's air pressure.
No, some people have physical ailments. They have to know what the barometer is when they leave the house.
Oh, that would be useful to that.
Well, if you have an altimeter, you need a barometer.
Yeah.
Exactly.
Yeah, so this is most commonly it's used as a rough altimeter. The basic idea, it's used with AGPS. It's helpful in figuring out your position. If the phone knows kind of how high up you are, it can find the satellites more easily. You could use it to write a storm detection app. If the air pressure starts dropping suddenly, hey, you got a tornado coming.
So you can use to mountain climbing, right?
Yeah. Although GPS would be a more accurate fix on that, but this could be used as a rough altimeter.
GPS can measure.
Yeah. It can measure altitude.
Oh.
You actually, when you poll GPS, you get longitude, latitude, and altitude.
Also, if you have a topo map stored in your phone, it can assume that you're on the ground.
Yeah, instead of skydiving. Or plummeting from a cliff. That's a good app. Call the ambulance when I've detected that I'm above the ground by more than 500 meters and approaching the ground at a rate of 9.8 meters per second. Yeah, snap a picture.
Yeah, you either call the hospital or the morgue.
Both. You're not going to have to pay for it.
Figure out
Help me.
car accident, how quickly you would stop.
Yeah. But yeah,
Actually, there are apps for that.
no, of course there's an app for that.
That detect, like if you're in a car accident or something, they detect the change in.
Yeah, a sudden
Right.
extreme deacceleration.
Right.
Yeah.
And then they'll automatically call like 911 or something. And
It's a good app.
Even gas leak in the Android car app.
I'm not sure if that would work with a barometer, although you would be able to detect an explosion. That's a change.
Briefly.
for a few seconds.
I would want to be the test person for that.
Anyway, similar to the barometer, a surprising sensor that shows up in a lot of smartphones and tablet devices. Humidity sensors provides data on relative humidity. Interestingly, you can use this to if you combine this with a barometer, there's a formula for figuring out what the dew point is. And I believe, although I wasn't able to find any documentation that expressly explained this, but I believe what this is likely included in a phone for is for figuring out whether you're in a condensing environment. If you're in a condensing environment, then your phone is likely going to get damaged because it's going to have condensation inside of it. But you could use it for other stuff, probably. I don't know. It's there, you can use it.
How many you went through so far? 13?
I have no idea how many sensors I've gone through so far. 12?
I don't think that that's electrically connected. Some have a little piece of like silica gel or pink stuff on the inside, and it'll make it change the color so they can decide whether to honor your warranty or not. Good sensor.
That's a separate thing. That's a moisture sensor. This is actually, you can actually pull this thing live. At least in Android devices, I know they have
I
them.
believe you, but I've never in my life heard of the phone have those.
I don't know why it has it. All I know is I read up the documentation. You can write an app that'll tell you what the dew point is.
They take them off.
I don't know why they put it in there, but it's there and you can use it and it's fun.
You can tweet it.
Temperature. Completing the trifecta of meteorological sensors that we don't need. Temperature. We have one or more sensors for determining temperature. There's actually, I noticed this in the Android environment at least, there were actually two separate sorts of temperature sensors. One of them is now deprecated. Originally, they have the internal temperature sensor, which was for detecting the temperature of the CPU or the battery. But they have recently come out with a standard for devices that have external temperature sensors. So this is probably included so that if you leave your car inside of, or you leave your phone inside your car, it'll be able to detect that and it'll stop running before it crashes. But you know, you can use it for whatever you want to use. Like I said, the sensors are there for a particular reason. I don't necessarily know what all of them are, but I do know that they are available to be used, and you might find something that'll be really popular, like the flashlight that burned out his phone. I'm sure Apple loves that app if it burns out lights and makes people buy new ones. No wonder it's so popular.
They gave me another one for free.
Oh, really? Nice.
And it wasn't Apple, it was Android.
Oh, okay. Even better. I like your phone. Magnetometer. Basically what a magnetometer is it detects nearby magnetic fields. It's useful for picking up nearby magnetically...
Junk on the beach.
Yeah, metal detector. Basically what this is a low-level sensor for the compass. That's why it's there. But you can write a metal detector app. They exist in the store. I've used them.
Find out, you know, like what the capacities are. Like, for example, there's no need to have like how hot, if the phone's going to be at 400 degrees Fahrenheit. Then, I mean,
Well, I think at that point it will reach it'll reach an error code at some point.
Well, how can we find out the parameters of all the sensors?
It's available in the documentation. Pretty much all you can get very, very detailed information on all the Android accessible sensors, and I'm pretty sure Apple does a pretty decent job of documenting their stuff, at least the stuff that they want you to use. Yeah, so that's all I have to say about that. That's it for the sensors. So RAM, storage, RAM, random access memory. This is what your device is able to think about at the moment. Typically in modern phones, you'll have 1 to 2 gigabytes of RAM. The important thing to remember about RAM is it's volatile and it's cleared with every power cycle. The thing you guys mainly need to remember is not all phones have the same amount of RAM, so you have to make sure you don't have memory leaks. You need to make sure that your apps have reasonable memory consumption. But aside from that, that's about all you need to really worry about. That and running out of memory. If you run out of memory, I believe you get a exception thrown.
How to check the memory size?
You can pull the operating system. I don't remember the exact procedure for doing it, but you can look it up.
What kind of phone? It depends on what kind of phone. And well, Android has 2 different platforms. So
Android has more than 2 different platforms. It has considerably more than 2.
This one you got to take out the chip, put it in the computer. As soon as you put it in the computer, it comes up.
Oh, you're talking about storage. We're talking about RAM here. Now we're talking about what you're talking about. Storage, internal storage, built-in space for long-term storage of data. Actually, it's not what you're talking about. You're talking about external storage. It's limited in its size. The main problem with internal storage is it cannot be expanded. And the bigger problem with that is some services are dependent on internal storage. Try to make sure that you're not overusing those, otherwise your users are going to hate your app. I had an ancient, really horrible Android phone that had like 512 megabytes of internal storage. I couldn't get text messages anymore after 2 years. That's the big disadvantage of internal storage, because you can run out of that very easily, and you can't offload it into external storage. External storage, the memory card, the thing he was talking about a second ago. Memory cards are micro SD format usually. This is where bulk data is stored. Things like pictures, video, audio. Large files can be stored there. You can specifically specify put it on external storage. The really nice thing about external storage is the user can upgrade it, so feel free to waste as much of it as you want, and the companies that make the SD cards will love you. It's usually in micro SD format, which has all sorts of copy protection stuff that we don't really care about. The cloud. Everyone loves living in the cloud. Cloud. So free. This is basically network offloaded storage. The basic idea is you get effectively unlimited storage, and it'll survive the death of the phone. So if you have pictures, you're taking pictures, you're storing them to the cloud, your car gets run over by a steamroller, you still have your pictures. Everything's good, except you need to get a new phone now. Big problem with cloud storage is it's only really available when the network connection is available. So if you're out in the wilderness, you won't be able to use cloud storage, which is unfortunate. Although most cloud implementations will cache stuff offline so that they can sync it when you get your data connection back. So you really won't have to worry about that too much, but getting into details. Another major disadvantage of cloud storage with smartphone devices is that it will eat your data quota. So if you have anybody other than Sprint, this could cause...
T-Mobile.
Oh yes, T-Mobile still exists. I forgot about that.
And they have unlimited 4G now.
Oh, nice.
So does Boost.
Yeah.
Boost is a subset of Sprint, isn't it?
Yeah.
Well, anyway.
Well, Verizon
But
has
they.
grandfathered.
In any event, if you have a data quota for your plan, it'll eat it up, and users don't like having overage fees in their data bills. So if you're going to try using some sort of cloud storage solution for your data storage, keep that in mind. You are allowed to store pretty much as you want to it, but you shouldn't access too much of it at any given time. Database. This is an internal storage. This is different from the other one in that it's managed by the operating system. Typically, a database will be an SQL type database. That means it's relational. By far the most common example of this is the contacts. In fact, you might go your entire life without using any other database other than the phone's contact database. But, that said,
That's not in the cloud.
No, it's not in the cloud. No, that's in your internal storage. That's one of those things that'll eat up all that internal storage space. I think that's probably what the problem is with my last phone. But anyway, databases. You have these available for you to use for your own things. Although since it's only being on one phone, it kind of loses some of the advantages of what you'll get with a normal database, the whole concurrency stuff. But relational databases definitely have their advantages, especially if you're going to do many-to-many relations. Does anyone know what I mean when I say that? Does anyone want me to explain what I mean, what I'm talking about when I say many-to-many relationships? No? Okay, good. Operating systems. All smartphones have an operating system. The main two are iOS and Android, although Windows is trying like hell to get into this. Symbian used to be the king of smartphone operating systems. It used to be like 90%, now it's like 1. RIM was also very popular. It was the old Apple. It had everything that wasn't Symbian, and now it's like 0.1. Bada. This is surprisingly popular in, it was either India or China, I don't remember, but it actually has a foothold in certain parts of the world. But you'll probably never actually have to deal with that. Probably what you're going to deal with is either Android or iOS, and that's why you're in this class. Operating systems is what handles multitasking or doesn't, and the operating system provides all sorts of services like telling you when the phone has changed orientation and that whole thing about not having to worry what sort of keyboard you're working with. Hardware abstraction. A lot of, though technically it's not part of the operating system, I'm pretty sure all smartphones have some sort of marketplace type thing. iOS obviously has the App Store. Google has Play. Basically, it allows for the management of applications. It allows you to download and install. They provide payment mechanisms, provide update mechanisms. At least in, well, actually no, on iOS too. There are alternative marketplaces from the one that the publisher provides. Although most of you probably won't have to worry about that because most of those are usually used for piracy.
You should put one more PowerPoint, spy on the user.
Yeah, you can do that too. It's useful. It's useful for you as a developer to be able to spy on the user. One interesting thing, Android, you can go around the marketplace. In iOS, you cannot. That's one of the biggest...
Jailbreak.
Huh?
Unless you jailbreak.
Unless you jailbreak, which is now actually illegal on tablets.
What?
You heard me.
When?
Like a week or two ago. Yeah, yeah, federal law. It's perfectly legal to jailbreak this, but if it's 3 inches bigger, you're going to jail.
Only iOS?
iOS.
Only Apple?
Well, technically, I think it would include Android. If they wanted to prosecute on that.
Yeah, but Android's not going to copy that size because they're going to wind up in court. So.
I really doubt that any Android manufacturer would go with that because it's open source. That's like its big selling point. You can do whatever you want with it. It's open. It's free. It would be a marketing disaster for them to undercut one of their biggest selling points. But anyway, voice recognition. You've all heard of Siri, right? It allows allows you to convert voice directly to text. It also allows control of the device via voice commands. That's Siri. Typically, this is implemented with sort of a server processing model, but for those sorts of models, you need a network connection in order for it to work. Google does have voice-to-text capabilities, so you are not limited on that regard. And the big difference between Google's implementation and Apple's implementation is Apple has more integration with the operating system, whereas Google's implementation is mostly a text-to-speech engine. Although they have apparently come out with a Siri alternative in their more recent version. I think it's Jelly Bean has that. Gestures! Everyone loves gestures. This is like when the simplest gesture you probably all are familiar with, has been around since the 80s, drag and drop. You also have drag scrolling. So on smartphones, that would be when you do that. You have the 2-fingered rotate, and at least I know in Android environment, you can actually make your own custom gestures. So if you wanted, you know, the old Greek alpha to do something, you can actually train it to do that. Gestures are really fun. They're a nice UI perspective. This is a thing you should probably keep in mind. Some sort of way of having some sort of motion triggering some sort of event, interacting with things.
Use pinch to zoom.
Huh?
Most applications that probably means you failed application UI.
Yeah, anything that requires zooming, you should probably use pinch to zoom. That actually brings up another slightly off-topic point. In UI development, there's this thing called an axiom, and it's basically the idea, or axiom, whatever. Basically, the idea is once users get used to doing things one way, you should always do it that way because that's what they're expecting to do. So even if there was an alternative to pinch to zoom, the fact that everyone uses it now, you should use it too. This is the gist of that. Near field communications. This is a contactless communication system. This is very popular in the new Android phones. I am honestly surprised that Apple didn't include it in the iPhone 5 because they were pushing for it. I don't know what.
It has to do with the wallet. That's what it is.
Really? No.
They have more patents. They don't want to go to court with Google.
That's not the only thing that NFC is useful for.
Yeah, the NFC is useful for a lot of other stuff. It's basically the idea with NFC is that the communication channel is very easy from the user to set up. You can transmit a very small amount of data very easily. It's a very low speed, so you wouldn't want to use it for anything large. You wouldn't want to use it for bulk file transfer. And it's a temporary connection, so you can't really use it for internet connections, although I suppose hypothetically you could.
Good app.
Oh, another neat thing about NFC is it's basically an extension of the old RFID tags. So you can actually get NFC tags, little stickers that you can place on things, and you can read data from them. It's neat. But most consumers probably won't have those, unfortunately. Mostly what it's useful for is being sort of a walkie-talkie between two devices. You can write apps that transfer data between two devices easily.
How far in proximity can you pick up the frequency?
I haven't really done a lot of experimentation with it, but most of the time it's about
It's like 3 to 4 inches.
about this far apart.
Is there any way to amplify that or anything? Use one of the other sensors to amplify?
Your users aren't going to be able to do that, and they shouldn't be relied on to.
Even if there was an app for that?
Oh, there's definitely no way to do it via software.
No.
Well, you think burning out your flashlight's bad?
It's going to be Harry Potter's wand next.
Yeah. Well, you could actually use it for that sort of stuff, although Wi-Fi would be a better choice for that sort of thing. I actually have a neat little thing in the back of my car, but I'm not going to go into that. I can control. I have a complete web server installed in the back of my car for controlling my stereo. Huh? No, it's a Hyundai Elantra. Anyway. Why would I ever say that, Joe?
He's like my granddad.
I'm teaching a class on mobile development. Seriously? All right, Bluetooth. Everyone's got Bluetooth, right? Most everyone anyway. iPhone's got it, Android's got it, BlackBerry's got it. I'm sure there's some Android devices that don't, but they're the sucky ones. Bluetooth is a useful short to medium range wireless technology. It's more, you could control something from across the room. Hypothetically speaking, I see that the distances you can control stuff for the really high-end stuff is supposedly about a football field away, but I wouldn't count on that. You should count on it being within about an arm's length away. Bluetooth is slow to medium data rates. You can use it for file transfer. You can use it for network access, although it's not particularly good for it. Bluetooth tends to set up more persistent connections than NFC does, so it's useful for the primary usage for Bluetooth is for hooking up the things that go in your ear and make you look crazy, and for hooking up keyboards, wireless keyboards.
Printers.
Yeah, you could. Oh, yeah, printers too. Yeah, actually, I hadn't thought about that.
It was actually introduced with printers.
Photo printers. Like
Yeah,
I had to do that.
totally didn't even think about that. You can also actually hook up a mouse via Bluetooth, although using a mouse under Android is awkward at best.
You could also use the Bluetooth for proximity with your GPS locator if you connect it to an interface.
Yeah, so,
And they're already
yeah.
doing that.
And hook up to your car.
Yeah. All right, FM radio. This is one of those crazy ones. There are a handful of Android devices that actually have an FM radio built into them. Although they're not really well supported, you can't really do much with them, but it's an interesting feature. I just figured I'd throw it in there because I thought it was kind of funny. You can also do TV outputs. This is exactly what it sounds like. This is an extremely rare feature that's not really used anymore. It's been superseded by HDMI out. It's kind of neat. Just figured I'd throw it in there because it was kind of neat. HDMI.
TV output, how does it work?
Yeah, you have a little thing you connect it to. You hook it up to RCA connectors, and bam, you get video on your screen. Basically, it like I said, it's been superseded by HDMI. So all the stuff I'm saying about HDMI goes back to TV output. It allows playback on larger screens. So if you can play a movie on your smartphone, but watching the Avengers like this is not exactly thrilling. It's a lot nicer if you can watch it in a nice 90-inch television that's mounted to your wall. So you can actually hook your phone up to your TV and play movies like that. It can also be used to provide a more traditional desktop-like environment. I have seen experiments with certain Android devices that when you plug them into an HDMI connector, you get an actual full desktop with a mouse cursor and everything. It's primarily used for video playback, though.
So a virtual computer, you're saying?
Yeah. Yeah, there's Ubuntu Mobile or something. I remember it's not really a very common feature. It's just sort of an interesting sidebar. And USB on the go. This is a very interesting feature that's recently come out. Usually when you do stuff with USB related on your phone is acting as a device that's plugged into some other thing, like a computer. It's acting as an endpoint. USB on the go allows your smartphone to act like a full-size computer. So you can hook up any sort of normal peripheral that you'd be able to hook up to USB to a normal computer. So mice, keyboard, hard drives, whatever. Network adapters. You could actually have a network adapter that you could plug Ethernet into to get network access on your phone if you can't connect to Wi-Fi. Unfortunately, it's not widely supported at this point in time because it's brand new. I'm getting very close.
So you could do an extension antenna app. Theoretically.
Hypothetically, you could write software that was for a piece of hardware that was USB that you could do something like that, yeah. But you would probably be working for the company making that hardware if you were going to do that, which is not impossible. People like that exist. Stylus, highly specialized user input device. It's very, very rare these days and age. It used to be very common for all sorts of resistive technologies. Right now, it's only really available on 2 devices, and those are both called the Galaxy Note, which is gigantic if you guys haven't seen it. Things like, hello?
It's cool though, it is cool.
Yeah, it is neat. It's much more common in much more older technologies. It's usually used with resistive technologies, but like I said here, the Galaxy Note, it's a capacitive technology, so that breaks that. And I believe that's my last slide. How close did I get?
Styluses for iPods and stuff.
Well, they do manufacture styluses. They're just not. They're an optional peripheral.
It's not considered to be different from finger.
Yeah, there's no yeah, obviously there's
from a software point of view.
Yeah, from a software point of view, there's no difference between touching it with your hand and using a stylus. Anyway, so your homework.
Good book.
This is the book that I have chosen.
Hello, Android.
I got it.
This is it focuses on the 2.3.3 Android development environment. They have been coming out with 4.x recently, but it's only like 5–10% of the market right now, and I have a feeling that most of you are going to be targeting 2.3 for the next 2 or 3 years. So that's why I'm going to focus on this. I'm going to focus on the 2.3 series. Your homework is to read chapters 1 and 3. You can skip chapter 2 for now because it goes into a level of detail that I don't think is appropriate until you've written 1 or 2 apps. But I will go over that later, so yeah, 1 and 3 are the chapters you're going to need for next time.